Hello, I'm Dr. Marion Carroll at Xavier University in the Department of Chemistry. And my colleague?
And I am Dr. Muhammad Qasim, the Department of Chemistry, Xavier University.
And what we were going to do is demonstrate experiment number 2, our pH determination. And what we will show you today, you will be responsible for performing in lab, and we'll just point out a few details that you might need to know and be prepared for. So, Dr. Qasim has his goggles, I have mine. Let's get to work. Okay, so in your experiment, we're going to be using the pH meters. Alright, these are our Denver Instrument, digital and quite reliable. You're going to need to use the maxi pipetters, the P1000s, a couple of beakers, and our solutions, which we'll talk about here in a second. And of course you'll need a little distilled water. The electrode that's connected to the pH meter is stored in a sleeve, and in the sleeve we have some water. Usually you put some buffer, but we use these regularly, so we put water in there to keep the electrode solution from drying out. The sleeve has to come off before you can do the experiment. You can put a little water in there and set it to the side until you complete the experiment and ready to put the electrode away. Okay, there is a sleeve on the electrode at the top that we must slide up. Okay, and that will open up a hole at the top of the electrode. This is where we usually put the electrode solution in, which is usually a potassium chloride, and that should remain open throughout the experiment. Alright, set it in here and we're ready to go. Okay, it's suspended here because we don't want the electrode to knock up against anything. It's very expensive, and so we want to take care of not to bump into anything. Alright, before we begin the experiment, we are going to have to calibrate the instrument. That means we're going to have to set the upper and lower limits for determining our pHs. And what I'm going to ask Dr. Qasim to do is to explain how we're going to do that, and then he will describe to you the buffers that we're going to use. As far as how much volume we're going to use, we're going to leave that for you to calculate and measure the pH. All right, Dr. Qasim?
Okay. Alright, so the first step, as Dr. Carroll just mentioned, which we are going to do, is to standardize the pH meter. The pH meter can be standardized by using two standard buffers, and they are both present in your drawer. One of them is yellow in color and the other one is pink in color. And these are the two solutions which are present in your drawer. They should be lying somewhere, not necessarily in the type of holder which I am holding, but one of them, you can look at that, is yellow in color. It has a pH of 7, so that's our standard of pH 7. The other one is pink in color. It has a standard pH of 4. So we are going to use these two solutions. The first thing which I am going to do is to rinse the electrode with water. So I will rinse it here with water and then gently wipe it with a paper towel. So I will wipe it with a paper towel here and then immerse the solution in pH 4 buffer. Again, as Dr. Carroll mentioned, that we need to be very careful that we do not hit the glass part of the electrode with any object. These are very fragile, but at the same time very expensive part of the equipment. Now when you dip it, you will see that there are some reading coming up on your digital display. It may not be 4.0, and that's the purpose of standardization. If it is, you are getting some value which is different than 4.0, then you need to hit the button which says standardize. So that's what I'm doing it here. I'm hitting the button standardize. So this should standardize the machine to pH4. Now you can see that, if you can see the display, it says 3.98 or 3.99, which is close enough to pH 4.0. So if it is within plus minus 0.02, you can accept that. The alternative is that if you are not getting the correct value, you can standardize a second time. Then hopefully you will get the correct answer. Now once you are done with this one, I will take it out here from the pH 4 buffer, and then I will wash the electrode again with water. And now I'm going to standardize the pH meter with this pH 7 buffer. And again the same is, I'm going to follow the same step, that I will wait till a S appears on the meter, and at that time it means that the readings are stable. So if it is not 7.0 at that time, then I will again hit standardize. So it should standardize the pH meter according to the pH 7 of the buffer which I am taking. So now you can see that on the reading on the meter it says 7.02, which is good enough. So now the pH meter is set for pH 4 and pH 7. Once you have standardized the pH meter, you can use it throughout your experiment in the lab. You don't have to standardize it again for several hours or for the duration of your lab. Now, you need to do the calculation. I have done the calculation, so I am not going to tell as to how much of the two buffer components I am going to mix. The two buffer components which we are going to use are 0.2 molar KH2PO4, and you may recall that's the acid part of the buffer because it has more hydrogen than the other buffer, which is K2HPO4. K2HPO4, which has less hydrogen, is the base part of the buffer. And remember that these acid, weak acid and their conjugate base, when they are mixed, you get a buffer. So I'm going to mix these two components in a proper ratio to get a pH of approximately 7.7. So you have to use a pipetter. In this case I am using 1000 microliter or P1000 for pipetting the two buffer components, and after I have pipetted the two buffer components, I will make up the volume by using the maxi pipetter. This maxi pipetter, it has these pipette tips which are present in your drawer. It fits here, and you can adjust the volume just like in the other pipetters. Like for example here I have already adjusted it. So you need to adjust the volume so that you can deliver the required amount of volume. Okay, here goes the second of those components. So now our buffer is ready. We have mixed the two, that is the acid component and the base component, but we are making a 10 milliliter solution of the buffer. So in order to make it 10 ml, what I am going to do, I will add up the volume of the two components which I have taken and then subtract it from 10 in order to find out as to how much volume of water I need to add. So I have already adjusted that volume on that maxi pipetter, and now I am going to add required amount of water using this maxi pipetter. So now our buffer is ready. Our buffer is ready. I'm expecting that if everything is right, its pH should be close to 7.7. It is never exactly 7.7, but if it is within plus minus 0.3 unit, it means that it's good enough. So that's now I have to check it using this pH meter which we have already standardized, whether its pH is close to 7.7 or not. Measure the pH of our solution by dipping the electrode into the solution. Again, you have to be very careful here that you do not hit hard your electrode with the glass container. Now, if you can see at the meter reading is coming out to be 7.4, it is within the expected range of 7.7. So I will say that it looks like that it's okay in this case. Sometimes if you are lucky, you can get even better result than that. But 7.4, if you are making a 7.7 buffer, 7.4 is okay. What we do in research is that we make the buffer like that, and then we can adjust the pH by adding either a base or an acid. In this case, if we really need a very exact buffer, for our research purpose, we can add a base and adjust the pH to 7.7. But for your purpose, it's good enough. And it demonstrates that the Henderson-Hasselbalch equation works okay for most of the purposes. Okay, so I think I have explained all the points, and we will be seeing you in the class. And if you have any problem, you're most welcome to ask any question about that.